Good morning, everyone. Thank you for joining us today. So, in our last explainer, we really dug into those foundational cloud models, IaaS, PaaS, and SaaS, and the amazing speed they give us. But that brings up a really interesting paradox in modern IT. If the public cloud is so great, if it's the future, why are on-premises data centers still a massive, multi-billion-dollar business? And that puzzle is exactly what we're tackling today with the hybrid imperative. We're going to break down why, for almost any large organization, the future isn't just one cloud. It's a permanent, strategic, and, yeah, sometimes complex. So let's jump right in. So this is the big question, right? With the incredible scale and pay-as-you-go economics of the public cloud, you'd think every single workload would have moved there by now. So why do companies keep investing millions in their own hardware? Well, the answer isn't that they're stuck in the past. It's because they're dealing with some very powerful, very real forces. We're talking the laws of the land, the laws of physics, and the simple, stubborn inertia of data itself. Here's our game plan for how we'll unpack all this. First, we're going to get on the same page by decoding the essential cloud models. Then, we'll dive deep into the core reasons that keep important workloads on-prem. After that, we'll look at the really clever ways architects are building bridges between these two worlds, tackle the huge challenge of managing it all, and finally, we'll boil it all down to the one key takeaway you need for your own strategy. All right, first things first. Before we can even begin to talk strategy, we have to be speaking the same language. This part is all about nailing down our definitions, because you hear terms like hybrid and multi-cloud thrown around almost interchangeably, but they actually mean very different things. This table lays it out perfectly, breaking down the three main deployment models from NIST. So on one side, you've got the public cloud, your AWS, Azure, Google Cloud. The defining feature here is multi-tenancy. I like to think of it as a huge apartment building. You get to share the cost of the foundation, the plumbing, the electricity with all the other tenants, which is what makes it so incredibly cost-effective and scalable. On the total opposite end, you have the private cloud. This is like your own single-family home. It's built just for you, and the main benefit is total control and privacy. And then there's this interesting middle ground, the community cloud, where a group of organizations with similar needs, say a bunch of research universities, get together and build a shared environment just for them. And this right here is the critical point. A hybrid cloud isn't just about having a private cloud and also using a public cloud. The magic is in the connection. It's about creating a single integrated environment where these different clouds are bound together, allowing your data and your apps to move between them. It's about making two separate worlds act like one. And this slide perfectly highlights that distinction I was just talking about. Hybrid, to be specific, means mixing private and public clouds. Multi-cloud, that's a whole different strategy. That's when you use services from more than one public cloud vendor. So maybe you run most of your apps on Azure, but you use Google Cloud's BigQuery because it's the best tool for the job. And here's the real kicker. A company can be, and often is, both. Most large enterprises today have a hybrid and a multi-cloud strategy. Okay, so we've got the what down. Now let's get to the real meat of it, the why. The decision to keep a workload on premises is almost never about someone just resisting the future. It's about running headfirst into powerful, non-negotiable business and technical realities that you just can't work around. And we can really boil all those reasons down to three main drivers. First, you have the laws of man, things like data sovereignty and all sorts of regulatory compliance. Second, you have the laws of physics, specifically the speed of light and how that impacts latency. And third, you have the laws of inertia, just the huge challenge of dealing with old systems and this powerful idea called data gravity. This quote nails the essence of data sovereignty, and honestly, it's often the number one reason for a hybrid strategy. What it means is simple. If you store your data in a public cloud data center that's in another country, your data could suddenly be subject to the laws of that country. For any company in finance, healthcare, or government, that's a level of risk they just can't accept. And here's a fantastic real-world example of this in action. In Canada, you have privacy laws like HIPAA that are super strict about personal health data. So to be safe, a hospital is probably going to keep its main patient record database in its own private data center, physically located on Canadian soil. But, and here's the beauty of hybrid, they can still use the public cloud. They might strip out all the patient names and personal info from medical images and send that anonymized data to a powerful AI service in the public cloud to scan for diseases. You get the best of both worlds. You stay compliant, and you still get to innovate. Okay, on to our second driver, the laws of physics. The public cloud is an absolute marvel of engineering. But even it can't defy the speed of light. It takes time for data to travel from point A to point B, and we call that delay latency. Now, for most apps, who cares? But for a growing number of really important applications, every single millisecond can be the difference between making money and losing it. Just think about high-frequency trading. These are algorithms making millions of trades a second. Even a tiny delay from a round trip to a faraway cloud data center could cost millions of dollars. That's exactly why these firms put their servers in the same physical building as the stock exchange. Or picture a factory floor with robots. The system that has to stop a giant robotic arm to keep a worker safe needs to respond instantly. You absolutely cannot wait for that signal to go to the public cloud and back when someone's safety is at stake. These kinds of workloads simply have to run locally. And finally, we've got data gravity. This is a really cool concept that has a huge impact on how big companies design their systems. So imagine a company has a 50-petabyte data warehouse. It's been sitting in their data center for 10 years, collecting every piece of customer data they have. The cost, the time, and the sheer hassle of trying to move all of that data to the public cloud is just mind-boggling. That data has its own gravity, and it becomes way easier to just bring the computing to the data by building new analytics apps on premises that can plug right into that massive database. So we've laid out the powerful why behind hybrid. Now let's get into the really clever how, because a good hybrid cloud isn't just two separate systems. It's about designing and building an architectural bridge between them so that your data and your applications can move back and forth to achieve a specific business goal. Cloud bursting is the classic textbook example of a hybrid pattern. Just follow the flow here. You're running your normal day-to-day business in your own cost-effective private cloud. Then, bam, a huge, unpredictable spike in demand hits. Think of a retail website on Black Friday. The application is smart enough to automatically burst into the public cloud, spinning up a bunch of temporary servers to handle all that extra traffic. Then, when things quiet down, those cloud resources are shut down and you stop paying for them. It's the perfect combination of on-prem cost control and the public cloud's seemingly infinite on-demand scale. And there are a couple of other really important patterns here too. Workload portability is kind of the holy grail, and we get there with technologies like Docker containers and Kubernetes. By packaging an app and everything it needs into a container, Kubernetes can run it pretty much anywhere. On-prem, in AWS, in Azure, it doesn't care. And then you have disaster recovery. The old way was to build an entire second data center that just sat there, costing a fortune. The hybrid way? You just replicate your data to cheap cloud storage, and only if a disaster actually happens do you spin up the expensive servers. It turns a massive capital cost into a small, predictable operating cost. So you're probably thinking, how on earth do you manage all this complexity without going crazy? The answer is infrastructure as code. Using tools like Terraform, engineers can define their entire infrastructure, servers, networks, everything in a simple text file. The beauty of this is that it's declarative. You just describe the final state you want, and the tool figures out how to make it happen. You can then check this code into a repository, test it, and use it to automatically build the exact same setup in your private cloud or any public cloud, making everything repeatable and consistent. And that leads us perfectly into what is probably the single biggest challenge of any hybrid strategy, the sheer operational complexity. You've got two different environments with two sets of tools, two security models. It's a recipe for headaches and mistakes. And the industry's answer to this is the quest for a unified control plane. The goal is something we call a single pane of glass. It's a great metaphor. Imagine one dashboard, just one single interface, where your IT team can see, manage, apply policies, and secure all of their resources. And they don't have to care if that resource is running in their own data center or thousands of miles away in a public cloud. That's the key to making hybrid manageable. And of course, the big cloud providers are all racing to build this, but they're coming at it from different angles. Microsoft's approach with Azure Arc is to extend its Azure management tools outward to your data center. You basically project your on-prem servers so they show up in the Azure portal, and you can manage them with the same tools your team already knows. Google Anthos takes a Kubernetes-first approach. Their goal is to give you the exact same Google Kubernetes platform to run absolutely anywhere. This ensures your applications and your team's workflows are identical, which is the key to real portability and avoiding being locked into one vendor. Okay, so a question might be popping into your head. We've established hybrid is complex enough. Why on earth would a company add another layer of complexity by going multi-cloud on top of that? Well, there are a few really strategic reasons. First, it lets you pick the best-of-breed service from each cloud. It gives you a ton of leverage when it's time to negotiate prices. And maybe most importantly, it gives you resilience. If one cloud provider has a massive outage, you have the option to fail over your most critical services to another.
Wow. Okay, we have covered a ton of ground. We've gone from the basic definitions to the deep business and technical reasons for hybrid, all the way to the architectures and management tools. So let's bring it all home and really synthesize the single most important lesson from all of this.
This right here. This is the one thing I hope you take away from our time together today. For almost every large company out there, hybrid is not some awkward temporary phase on the way to being all in on the public cloud. It is the destination. It's a conscious, long-term strategy. It's about finding that perfect balance between the amazing innovation of the public cloud and the unavoidable real-world constraints of your business. It's really a change in mindset, away from a blind, cloud-first approach to a much smarter, workload-first approach. You figure out the best place for each application based on the hard rules of data sovereignty, latency, and data gravity, and then you use these new unified control planes to manage the whole thing as one cohesive system.
And this whole idea of bringing cloud-like capabilities to where they're actually needed, that's the perfect setup for the next big frontier. If hybrid brought the cloud model into your data center, then the rise of the edge is about pushing it out even further into factories, stores, cars, and more. We'll be exploring that incredible new world in our next series. Thank you so much for joining us for this deep dive. If you found this valuable, please subscribe to our channel, Tech, AI, and Beyond, so you don't miss what's coming next. We'll see you then.